Hi, good afternoon, everyone. My name is Natalie Unwin-Curinary, and I am the Associate Director of Education at the Earth Institute. I'm very pleased to welcome you all to today's annual Student Research Showcase. Each year, the Earth Institute hosts this event to highlight the work that students across the university are doing on environmental and sustainable development issues. Today, you will hear from about 25 students in a series of short, pre-recorded videos where they will share some key insights about the research and the projects that they've done over the past year. As you will see, they have a wide range of research interests ranging from environmental geochemistry to renewable energy and climate justice. And so today we've grouped their videos broadly by 5 thematic areas: climate change, earth science, community development, health, and international development. Following each video segment, we will bring the students on screen live to answer questions. You can type your questions at any point during the video into the Q&A box. The video will begin now with a short welcome from the Earth Institute's director, Alex Halliday, and then we'll get started with the first segment of questions from climate change.
Good afternoon, everyone. My name is Alex Halliday, and I'm the director of the Earth Institute. I am really pleased to welcome you to the annual Earth Institute Student Research Showcase. Each year, Columbia students undertake impressive, independent research related to earth sciences and sustainable development, and support the work that faculty and researchers do to understand the Earth's systems. In doing so, students gain valuable hands-on research experience and professional skills while contributing to the development of solutions to environmental challenges. Typically, their work is conducted in Columbia labs and at off-campus locations throughout the United States and abroad. Due to the global pandemic, students were not able to travel this year. That didn't stop them from working remotely on some truly incredible projects. Today, we gather virtually to celebrate their work. This year, 56 undergraduates, masters, and doctoral students from across Columbia were funded through the Earth Institute student programs. These include an internship program, an undergraduate research assistant program, a collaborative research grant, and other grant opportunities. In total, the Earth Institute awarded over $140,000 this year to support students. The topics these students studied ranged from biodiversity to urban planning, and from earth sciences to international development to climate change law. And they worked across nearly all of the Earth Institute centers and affiliated units. Today, we will show a video featuring about 20 students who will talk about their work. After each video segment, these students will be available online to answer your questions live. So thank you for joining us. Stay safe. I hope you're enjoying your student experience despite everything and the difficulties. The video will begin shortly.
Hello, my name is Karen Copeland, and I am a second-year undergraduate student at Columbia studying Earth and Environmental Engineering. This past semester, I worked with Dr. Maria Tezzorzio's Biooptics Lab on a project focused on studying the relationship between wastewater outflow and the COVID-19 pandemic. This project was spurred by an article that discussed the differences in New York City's population during the pandemic. Roughly 5% of New York residents left the city from March 1st to May 1st, and this trend was even larger in the wealthier districts such as the Upper East Side, where population decreased by greater than 40%. My project's goal was to take this trend and connect it to wastewater outflow. Understanding wastewater outflow in New York is especially important because 60% of our sewer systems are combined, meaning that they treat both stormwater and wastewater together. And when there's a lot of rain, these systems become over inundated and they overflow, and they release untreated water into surrounding water bodies. After collecting, cleaning, analyzing, and visualizing outflow data from wastewater treatment plants throughout New York and Connecticut, we discovered that there was indeed a clear decrease in wastewater outflow in the earlier months of 2020 as compared to the previous 3 years, especially in wealthier neighborhoods like Manhattan. Additionally, from studying all this data, we were able to derive clear seasonal and temporal trends of wastewater outflow, which is important to understand because it allows us to connect differences in water quality to wastewater outflow itself. In the future, we hope to look into contaminant concentrations in wastewater effluent and connect that to ecosystem health. Thank you.
Hi everyone, my name is Maya Venkatraman, and today I will be describing my research done with the Esposito group in the Chemical Engineering Department and the NACIS group in the Earth and Environmental Engineering Department. My project is called Minimizing the Levelized Cost of Hydrogen through Dynamic PEM Electrolyzer Operation. Hydrogen is an element that, as a fuel, has tremendous potential to store renewable energy in times of peak generation. My research focuses on electrolytic hydrogen. Hydrogen formed by splitting water using a protein exchange membrane electrolyzer, thereby releasing no CO2. So, what made this work novel? In previous studies, researchers operated the PEM electrolyzer at the same current density throughout, producing a constant amount of H2 per given time unit. My research investigates dynamic electrolyzer operation, allowing the current to vary to minimize the levelized cost of hydrogen depending on real-time electricity pricing. An example of this in practice is the following. Imagine a hot, late afternoon where there is low generation from renewables and high demand. We would pick an extremely low current density to run the electrolyzer in this scenario, since pricing will be so high. Now imagine a very windy day with excess wind energy production, where energy demand is very low. In this scenario, our algorithm would pick a high current density and generate many more kilograms of hydrogen than it had been in constant operation and at low cost. Hence, dynamic operation has huge potential in terms of making electrolytic hydrogen commercially viable, since it presents an optimal method of maximizing production while minimizing cost.
Hi everyone, my name is Natalie and I'm a second semester student in the Masters of Sustainability Science program. In the fall, I was hired as an intern through the International Research Institute for Climate and Society, working on the Climate Information for Pest Oriolis project, which I'll be continuing this semester. The project is part of Colombia's Act Today program, and my work focuses on the climate needs of Pest Oriolis in Senegal. I'm performing a comprehensive literature review to better understand the current state of climate services in the country and identify gaps and areas of opportunity for Act Today to improve the availability and use of climate information. Pest Oriolis in the Sahel region are deeply vulnerable to climate variability due to their strong reliance on rainfall and availability of fodder to feed their herds. Studying the decision-making mechanisms of this population has been super interesting because of the complexity of the compound risks Pest Oriolis face. Breeders respond to these risks through a variety of activities, which may include livestock diversification, short-term migrations, and inter-ethnic resource negotiations. Having a better understanding of the existing risk management strategies Pest Oriolis use will help Act Today better serve the climate needs of these producers.
Hi, my name is Jenny Bach, and I'm a graduate student at Columbia's MPA Environmental Science and Policy program.
I'm Ellen Scott. I'm a senior at Barnard College studying environment and sustainability. And we are presenting to you our research this past year at the Earth Institute. Heat is a deadly health issue that is only worsening with climate change. Unfortunately, this burden of heat exposure is not equally distributed due to a history of racially discriminatory urban planning practices. In New York City, Black people accounted for 50% of heat-related deaths, even though they only make up 25% of the population. Our research examines the health impacts of extreme heat and policy solutions that address the issue in partnership with environmental justice groups. We're conducting literature and policy research and statistical and GIS analyses so that we may recommend more effective and equitable city policies.
Results from a survey conducted with local EJ group WEAC to evaluate how people coped with heat and COVID-19 during summer 2020 showed more people stayed at home. This likely increased reliance on indoor cooling and the risk of heat-related health issues, as most heat-related deaths occur at home in New York City. Our results also indicated a racial disparity in AC ownership and a lack of access to green space, which are trends supported by our literature review. Our research has highlighted the urgent need for permanent funding of heat resiliency initiatives like the city's free AC program, cooling centers, targeted tree planting, and the Be a Buddy program. We also recommend the city improve its heat vulnerability index to more precisely capture health and climate data.
Hi, my name is Julia Bontempo, and I'm a Sustainability Management Master's student at Columbia University. I'm interested in city scale resiliency projects. And so for the past 2 years, I've been specifically researching urban heat islands and heat vulnerability with organizations like Urban Design Forum, the New York City Mayor's Office of Resiliency, and now Columbia University. Through the collaborative research grant, I've been investigating the relationship between land surface temperature and land use change and how that relationship has developed over the past 20 years. I'm using NASA's Landsat imagery, as well as New York City's LiDAR data set, which tells us what parts of the city are covered in trees, grass, roads, etc. These two data sets have let me visualize answers to questions like, does surface temperature increase in areas where there has been recent development? Or what neighborhoods are heating up most quickly? And what are the built environment characteristics of some of the warmest neighborhoods? I hope for my research to illustrate the threat of extreme heat and how it's changing over time, as well as offer insights into the best ways to mitigate heat vulnerability through land use change.
Hi, I'm Justin, and I'm the Act Today intern at the IRI. For our research, we're tackling climate change as it affects smallholder coffee farmers in Ethiopia. Smallholders make up a significant portion of Ethiopia's GDP, but unfortunately are struggling to break even, mostly due to high variable costs from increasingly volatile and intense climate events. The overarching goal of our research is to help sustain their livelihoods by developing a digital advisory tool that would allow smallholders to make adaptive management decisions based on probabilistic climate data. To accomplish this, I have been collecting climate data such as monthly temperature and precipitation from all 66 coffee growing zones in Ethiopia, as well as survey data on cost structure for smallholders and daily prices from the Ethiopian Commodities Exchange. With this data, we'll use a multi-level panel analysis to determine seasonal correlation between climate parameters and profitability to then input into the digital tool. Thank you.
Hi everyone, my name is Gabriela Slava, and during fall 2020, I worked as a graduate research assistant at the Sabin Center for Climate Change Law on the Law and Science of Climate Attribution project. This project examines how attribution science is used in litigation and in policymaking, and how litigation and policymaking might influence current and future directions in attribution science. Specifically, I conducted a literature review on scientific papers to fit the database on 4 different categories: climate change, extreme events, impact attribution, and source attribution, before it was launched in December 2020. I also led the translation of the paper's abstracts to Spanish to broaden the database reach. Thank you very much.
Over the course of 4 days, Hurricane Harvey unleashed 30 million Olympic-sized swimming pools of water over Houston. This reminded Houstonians, myself as one, of our flood exposure. But the real reminder was that not everyone has the same ability to respond and to recover to flood disasters. And that's the key. So working alongside supervisors and mentors from the Earth Institute, Dr. Carolyn Holtquist and Andrew Kruskovets, we had the privilege using Houston as a case study to research, identify, and understand what factors make someone more vulnerable to flood disasters than others. And with this work, create a flood vulnerability index and geospatial map for Houston. While I quickly found out how nuanced this work is, I'm really excited about what we produce because it can help inform both community advocacy efforts and flood policies and prioritization mechanisms. Please visit our project story map to learn more about the story of flooding in Houston, indicators of flood vulnerability, and I call on you to use this work to advance equity and justice in flood resilience planning and response. Thank you.
The goal of my research was to translate flood algorithms developed for Bangladesh to the Nadinya Department of Columbia. Since the algorithms rely on Sentinel-1 satellite data, I had to assess the feasibility of using them in a new region, considering differences such as satellite coverage patterns and topographical obstructions. Using 5 flood events as case studies, we concluded that it is not possible to use Sentinel-1 satellite data to track floods in the region. Due to the quick movement of water, the dense vegetation, and satellite complications in urban areas, the possibility of using Sentinel-1 in Colombia is drastically less certain than it is in Bangladesh. Of the 5 flood events assessed, events 2 and 5 yielded slight flood detection using Sentinel-1, but compared to media reports, it is likely that the results from these 2 events were still strong under predictions of inundated areas. This semester, however, I'll be testing the algorithm in 2 new departments of Columbia with different vegetation and topography in order to have a more comprehensive understanding of Sentinel-1 behaviors and its overall potential for detecting floods in Columbia.
Hi, my name is Emily, and this spring semester I am completing a research assistantship with the Columbia Center on Sustainable Investment. So more specifically, I'm working with the COMET team, and COMET stands for the Coalition on Material Emissions Transparency. So the overarching aim of COMET is to develop a harmonized carbon accounting framework for mineral and industrial supply chains. And this is important because even though we have lots of different ways of calculating the emissions of a certain product, if those aren't standardized, it makes it very difficult for us to implement policy to reduce those emissions. And so COMET is trying to solve that problem by creating a harmonized framework. And so in order to help COMET in its purpose, I have been doing some research on the existing frameworks for reporting emissions in the materials sector, which should hopefully help inform COMET's work going forwards.
I'd now like to invite all of the students who were featured in the climate change segment to turn on their videos and join us for live Q&A. So I see one person had asked perhaps Colleen Neely to share the story map for the Houston flooding in the chat, so we can certainly do that. Another question for Colleen was for what indicators did you find significant for flooding vulnerability in your research? And Colleen, you're on mute.
Okay, thank you for that question. So we looked at, the project started with a fairly deep dive in literature review, and we ended up compiling just about 15 variables. The most significant ones that influence flood vulnerability, as far as we found for our case study with Houston, is poverty or your income level, indicating if you are lower on the income level, as well as minority status. If you are non-white individual, that ranked higher in terms of your flood vulnerability, as non-white individuals generally have are marginalized in certain ways that can make them more vulnerable and more and have greater difficulty in responding and recovering to flood events. But there's a number of variables that we included, and I will share the link to the project in the chat such that you can see all the variables we included, but there were a number of them. And thank you for the question.
Thank you, Colleen. I'll pose a question to Jenny Bach and Ellen Scott. Can you speak to some of the specific deficiencies that you identified in the existing heat vulnerability index? And did you find any connections between heat vulnerability and the COVID-19 pandemic?
Yes, I can start with the New York City's heat vulnerability index that actually Columbia researchers helped create. We found that there just generally it does has like 5 variables, including green infrastructure access. It does also look at income and uses race as an indicator. And one thing we did find just in general was the resolution could be more fine detailed. The city still, you can't really look on a like address specific level. You can only look on zip code level, and just the type of temperature data they use is not necessarily as accurate because they use surface temperature, but actually air temperature is more accurate for determining like thermal heat comfort. And they actually, the city did just include a new variable, AC access, which is really key. And that's something that was addressed also with COVID being a compounding risk. Maybe Ellen, you want to talk about the free AC program?
Sure. Yeah, so in terms of your question about COVID, we did find that the usage of green spaces and other kinds of cooling amenities in the city were used less because of fears about, COVID and social distancing guidelines. And so the city did implement a free AC program so that we could target, vulnerable people inside their indoor apartments. And so the concerns with COVID are really having people isolated inside their indoor dwellings, which made it that much more difficult to find cooling amenities and resources.
Thank you both. A question for Justin Chan. Can you speak a bit to the existing infrastructure in Ethiopia that's available to implement the digital tools that you've proposed?
Yes, so we're working right now with a variety of groups in Ethiopia. A lot of them are like coalitions that are helping gathering data, like farming data and climate data for us to use to build this tool. And the reason we're working on this is because there's kind of a lack of infrastructure and resources that they can use. And we are also wanting to help the smallholder farmers who don't really have access to this.
Thank you, Justin. I think we have time for one more question, which I will pose to Emily Spittle. What are the biggest obstacles that you found are for, block or challenges for developing a comprehensive framework for materials emissions in the supply chain?
So basically, the current state of affairs is that we have lots of different guidelines and standards that tell us how we can calculate emissions for a certain product or organization. But a lot of them lack a lot of details. So when you apply them to different industries, it creates differences that make the data incomparable. And also the different frameworks have aspects that make them uncomparable. And part of the problem is that a lot of emission reporting right now is also voluntary. So there's a lot of freedom for organizations to pick which framework they use. And then there's a lot of flexibility within those frameworks because there's not really pressure right now to make it harmonized. And so that's the sort of key issue we've been looking at in terms of how, when like reporting is still voluntary, that we can actually make it so the data is comparable.
Great, thank you. And with that, we will move on to the next video segment, which is on community development. So I will ask all of the students to turn off your videos and we'll get started with community development.
Hi everyone, my name is Lauren and I'm an intern at the Earth Institute in the Diversity, Equity, and Inclusion Department at Lamont. And over the past semester, I've been working with Ben Kiesling and Kailani Acosta to create Columbia Climate Conversations, which is this really cool panel series that kind of tackles diversity in the geosciences and in climate action in a way that we've really never seen before. The first event that we put on was Intersectional Environmentalism in November with 3 amazing climate activists basically talking about the ways that people of color have not been represented in environmentalism and ways that we can be more diverse and inclusive in our approach to climate action. And the most recent event that we put on was Youth Activism in Action, which was amazing panelists who were all under the age of 18 talking about their experience in environmentalism as young women of color. So we're really excited for this. The next event will be Small Island Sustainability with Caribbean activists. And it's really great to see this representation happening here at the Earth Institute.
Hi everyone, my name is Divya Gawala and I am a communications intern at the Earth Institute. Today, our youth is at the forefront of the climate action movement, demanding a more equitable and resilient future. So for my internship project, I designed the Emerging Climate Leaders Policy Workshop, which aims to help students translate that aspirational sentiment into actionable policy initiatives. The program is open to students grades 9 to 12 from all over the US to ensure that our discussions have diversity in experiences and political opinions. To reenact the policymaking process in the classroom, I've adapted activities from the SEPA graduate program, such as stakeholder debates and policy analyses, to the high school level. Designing the curriculum step by step with input from my colleagues and professors every step of the way, was an incredibly thorough and thought-provoking process, and I can't wait for students to experience this in March. Thanks for watching.
I'll now invite Lauren and Divya to turn on their cameras and join us for live Q&A. And again, attendees, you can type your questions into the Q&A box and we will answer them live. But as we wait for questions to come in, first question for Lauren. How could Columbia's climate conversations contribute to the overall diversity, equity, and inclusion efforts at Lamont? And what would be your recommendations and next steps?
I think Columbia Climate Conversations serves as a really good jumping off point just in terms of education, first and foremost. I think a lot of the issues that we've tackled thus far with the two panels that we had after the two that I mentioned. So we had one, the Small Island Sustainability panel, which was talking a lot about, basically Caribbean climate activism, but also the situation, the dire situation for Caribbean islands in climate action, but also ways that scientists can interact with local communities in a way that fosters community, but also values their perspective, as well as the panel that we had last night, which was about disability justice and ableism in climate action, which is again, something that we don't really hear talked about very frequently. So I think Columbia Climate Conversations is a great way for the Earth Institute, for the environmental community here at Columbia to learn more about these issues. And also at the end of every panel, we also talk about what the next steps are, what we want to see in terms of development, in terms of improvements to be made. So I think from there, it's definitely a great way to hear about ways that you can get involved, hear about ways that you can improve and be more inclusive in your approach, and things that you probably never heard about before in terms of things that you might have been doing that may have been hindering diversity, equity, and inclusion. So in that way, I'm definitely think there's a lot of overlap in ways that Columbia Climate Conversations can really be beneficial for overall DEI efforts here at Columbia.
Thank you. We had a question come in that was for both Lauren and Divya, and maybe we'll start with Divya answering it and then move back to Lauren. But what career paths and jobs do you see youth activists working on climate change taking post-graduation?
Yeah, that's such a great question. When we were looking at the applications for the program, we got a really wide range of applicants, and many of them were interested in climate research, even at the high school level, which I thought was very inspiring. So I think that many of them are looking into climate research initiatives. Many of them are looking into climate policy initiatives. And one of the great things about the workshop was that they were actually able to, as their final project, analyze a congressional bill. And so many of them said that definitely moved them to consider a career in environmental policy later, either at a think tank or even in politics.
I think just kind of adding on to that, yeah, there's definitely a lot of room for career paths within sustainable development and within climate activism. I think kind of adding on to one of the ones that Divya might not have mentioned is also environmental justice law as well in terms of policy, but also environmental and sustainability consulting is something that I've heard talked about a lot, especially within this field. So there's definitely a lot of room when it comes to sustainable development to find different career paths. Even health, sustainability in like public health, DEI and public health is something that don't really think about that often when it comes to sustainable development, but yeah, there's a lot of room for different career paths because I feel like sustainability kind of trickles into every aspect or any career it can be applicable to. So.
Great, thank you for that. And then one final question for Divya before we move on. What sort of support do you think that youth climate leaders need the most?
I think that the biggest support that we could give them is just access to opportunities, because so many of them have the sentiment of wanting to see change in our current systems, whether that be the economic systems or political systems that are currently leading to the issues that we have. And I think that if we really give them opportunities like the Earth Institute is providing to high school students and to undergraduate students every step of the way, then that'll really help them translate their emotional sentiments, which are already there, into quantifiable action.
Great, thank you both. Now we will move on to the Earth Science segment.
Hi, my name is Emma Layton, and I am an Earth Institute research assistant working with Professor Yochanan Kushner. My project explores the impact of extratropical volcanism on Euro-Mediterranean climate. My research was originally inspired by a recent paper suggesting that the Alaskan Okmulgee volcano that erupted in 43 BC may have caused climatic changes that caused famine and political instability, leading to the fall of the Roman Republic and Ptolemaic Kingdom and subsequent rise of the Roman Empire. I am using hydroclimate data from the Old World Drought Atlas to look at shifts and patterns of change in hydroclimate during and after major extratropical volcanic events. The Old World Drought Atlas is a paleoclimate reconstruction of the Euro-Mediterranean hydroclimate using old tree cores from the region. Through my work, I hope to be able to verify and quantify the impact that the Okmulgee could have had on the Mediterranean region and how much it could have contributed to these very significant historical events.
The goal of this research is to understand how sea surface temperatures have changed in the eastern equatorial Pacific over past glacial and interglacial periods. The data in this research was sediment cores from all over the eastern equatorial Pacific, and the data was compiled from previously published records. These studies measured the del-18 of G River, which is a proxy for past sea surface temperature and global ice volume. By focusing on del-18 values during glacial and interglacial periods, we were able to achieve a better understanding of how the del-18 changes at different latitudes through time. We found that global glacial cycles affected the sea surface temperature in the eastern equatorial Pacific in the past 130,000 years. We demonstrated a sea surface temperature gradient with latitude in the eastern equatorial Pacific at 3 periods during this time, supporting the continued presence of the equatorial front. Knowledge of the eastern equatorial Pacific mean state will inform research on its variability through time, such as by changes in ENSO dynamics.
Hi, my name is Sophia Sanchez, and I'm a junior undergraduate student studying computer science at the School of Engineering and Applied Sciences here at Columbia. This past semester, I worked on a project titled Identifying Basal Crevasses Underneath Antarctic Ice Shelves using NASA IceBridge radar data under Dr. Indrani Das. Ice shelves are extremely important for the overall structural stability of the Antarctic ice sheet. So what we did was took NASA airborne radar data and then processed it through the CREASES toolbox, which is a MATLAB-based semi-automatic picker which goes through and selects what is the surface and base of the ice. We were particularly focused on the basal crevasses, so then I went through and I handpicked each feature that I found in the base of the ice shelf and then compared it with the CREASES data. This data will then later help us predict where the ice could potentially break off and form icebergs, which is correlated with sea level rise, as well as try to tie a periodic function to the occurrence of these the occurrence of the crevasses.
Hi, my name is Celeste, and I worked on a project set to be published later this year called The First Measurements of Ambient PM 2.5 in Kinshasa, the Democratic Republic of Congo, and Brazzaville, the Republic of Congo, using field-calibrated low-cost sensors. Over the past few years, there's been a growing concern for air quality as it causes numerous health concerns and environmental issues. While we know this is an issue, it is hard to address because there's a very large data gap where the areas that we know have the poorest air quality lack reference grade data. This is because reference grade air quality monitors can be very costly. This project set out to address that issue by using machine learning to calibrate low-cost sensors with reference grade data and apply that model to a low-cost sensor network to obtain the first repeatable measurements in Kinshasa and Brazzaville. And hopefully these measurements will help inform air quality policy changes in these cities.
Hi everyone, I'm Sarah and my research is focused on fine particulate matter, also called PM 2.5, and meteorology over India. In recent years, India has had extremely high PM 2.5 levels, which is harmful to health, and India also lacks long-term observations of PM 2.5. So what's exciting about this research is we're using a new chemistry climate model with 12 ensemble members that allows us to look at historical changes in PM 2.5 in India. This allows us to separate the roles of emissions and climate variability in rising PM levels. And what we found is that while there is variation in meteorology between the ensemble members, all scenarios show significant increases in PM across India, which corroborates the dominant role of air pollutant emissions on poor air quality.
My research focuses on constraining the timing of iceberg activity, as well as the abundance of it, in the southern portion of the subpolar gyre during the last glacial cycle. This region has not received significant attention in the past due to the difficulty posed by dating low calcium carbonate sedimentary records, which characterize much of the sediment in the area. However, The calcite lysocline, or the depth at which calcite is no longer preserved in the sediment, shoals during interglacials and deepens during glacial periods. This provides a relative dating framework, which we concorded with a benthic foraminiferal stable isotope record to confirm. In conjunction with the calcium carbonate record, quartz and other lithic fragments larger than 150 microns, which is a size fraction prohibitive of transfer by means other than by ice rafting, were counted to reconstruct the abundance of iceberg activity over these core sites. We confirmed that there was an increase in iceberg activity in this region during glacial periods and are working to better constrain the exact timing and positioning of iceberg pathways in the subpolar Pacific Ocean.
Okay, I will invite the students in the Earth Science segment to turn on your videos and join us for Q&A, please. Great, welcome. So we're collecting questions in the Q&A box. Question that has come in for Celeste. Wondering if you have a specific policy recommendation for lowering the local PM 2.5 that is emerging from your work. And also congratulations on your paper.
Hi, thank you, Arlene. So a couple of things that we found that the average yearly PM 2.5 in Kinshasa was almost 4 times the World Health Organization's annual mean guideline, which was very concerning. And so when we looked closer at the data and looked at the diurnal trends, we saw that there was a really heavy morning and evening peak, which probably coincides with traffic, but also could have to do with forms of like cooking that may emit a lot of like forms of cooking that may emit a lot of PM 2.5. And so and when we also looked at what these values look like in different sites in the network, we noticed that for example, the site that a lot of like ambassadors live at didn't have as much of that evening peak from like the cooking and the traffic. So obviously there's some lifestyle, like cultural or some disparities in terms of who can access certain technologies that emit less PM 2.5, and we can see that throughout the network. So probably like regulating traffic and different cooking technologies, or making sure that there are sustainable like options that are accessible to like all populations there. So yeah.
Thank you, Celeste. And staying on the topic of PM 2.5, I'll pose a question to Sarah. What is the current monitoring system in India, and do you have any recommendations to improve the national system, or any lessons drawn from your research?
Yeah, so I think now there's a lot more monitors than there used to be. Like, that's why it's so great that we have this model that goes back to 1950. But just in general, adding more monitors, I think, is the best way to go. The observational data we used in this research was from US consulates and embassies. But yeah, there could be a lot more monitors for sure. Maybe with Celeste, they could put more low-cost monitors in there too.
Thank you. A question for Bryn. What was the most difficult part of your research, and how did you overcome it?
Probably the most difficult aspect of my research was finding open source data that covered a long period of time, that also was the exact type of foraminifera that I was looking for, as my project was using entirely open source data over periods of time that were hundreds of years old.
Thank you. And a question for Sophia. And again, we're collecting questions in the Q&A box, so feel free to type those in there. But Sophia, can you speak a bit to the practical applications of your research?
Sure. So being able to predict where and when ice shelves will break off will help us determine how much sea level rise we might see within the coming years, and more accurately be able to develop either environmental policies to prevent this, or determine like where there might be more climate refugees coming from. So it's a lot of logistics in terms of like what parts of Earth will still be habitable.
And I'd pose the same question to Cassandra, if you could speak a little bit to the practical implications of your research as well.
Yeah, so understanding the carbon storage dynamics of the North Pacific are really important in understanding and constraining the global carbon storage possibility of the ocean. It's a little bit backwards in the Pacific, but understanding exactly the movement of the lysocline can really give us a better idea of how much carbon is being sequestered in the Pacific at any given time. And in addition, the movement of icebergs can give us a better full understanding of the dynamics of the subpolar gyre, which is also plays a really important role in upwelling in the North Pacific. So getting a better understanding of the icebergs will help us out there.
Thank you. And I think we just have time for one quick question for Emma. Can you tell us a bit how your research method could be applied to other cases?
Yeah, of course. So basically, what I did was I looked at PDSI data from pre and post eruptions and looked for any statistically significant changes post volcanic event. And that kind of thing is important for understanding that method could be used to pinpoint the effect of geologic events like volcanic eruptions that tend to happen over time and can have really severe implications for the agricultural and lifestyle habits of the region. For example, there was a lot of really significant wetting in Southern Europe and the Mediterranean and really significant drying over Central Europe. And that could be really devastating for people's way of life. So understanding the implications of those types of events and how even geoengineering solutions like putting sulfur dioxide in the atmosphere could affect different people around the world is really important.
Thank you all. And so we'll move on to the fourth segment, which is focused on health.
I work at the Rural Community Assistance Partnership, or RCAP for short. RCAP helps small communities, those with less than 10,000 people, ensure that they have safe drinking water. I will be working on the lead and copper rule and helping communities comply to the new rule revision that is going to go into effect in 2024, assuming no changes occur before then. This is the biggest revision to the rule since 1991, so there will be many new rules to follow, such as taking inventory of all lead service lines, testing in schools, and a change in sampling procedure. So I will be educating the public and educating those that work in the RCAP network and people that sit on water boards in various communities across the United States to help ensure that they are informed about the rule and that they can comply and that they have the necessary funding to do so.
Hi, my name is Sonia Mahajan, and I'm a February 2021 graduate from Columbia College with a BA in political science and a special concentration in sustainable development. From November to February, I worked with Dr. Joyce Klein Rosenthal on her project, the American Lead Atlas, which is a map basically of where environmental lead risks lie in cities across the country. So although lead-based paint has been banned in the United States since 1978, there's still a huge risk of exposure from either paint in older homes or other sources of environmental lead, especially in cities because they are built environments. And there's no safe amount of lead exposure, especially for children under 6. It can result in severe injury or even death. And there isn't a lot of information out there about where lead is and how to avoid it. So that's the problem that the work that I worked on is trying to solve.
my project was to use satellite gathered data on a vegetation cover index to predict food insecurity in a few sub-Saharan African countries. And so the major stumbling block we ran into in this project was that data on things like crop yields and total production is scarcely available and unreliable in these countries because the main agricultural production is rural farmers engaging in subsistence production. And so there's no central authority that collects data like this. And so when we built a model that predicted food insecurity based off of these this satellite data, we found that it predicted food insecurity and total production well in places like India and Vietnam, where reporting is reliable, but it didn't accurately predict that well in places like Ethiopia and Senegal. And so our analysis showed that while this methodology behind predicting food insecurity is sound, the main thing that needs to change is that we need more accurate surveys of food production in these rural areas in order to accurately forecast food insecurity.
Arsenic is a pervasive groundwater contaminant in the upper Midwest US, both because of high natural occurrence and a disproportionate use of private wells. And this is especially important in Native American communities. Our goal is to understand key environmental drivers of arsenic contamination and find remotely sensed predictor variables to link these drivers to statistical models and be able to know where to expect high arsenic. We hypothesized that NDVI, or vegetation greenness, would be a strong predictor because areas that are greener are wetter, and this is associated with high arsenic mobilization. We averaged NDVI values for each month across several years and found that NDVI changes seasonally with greener periods in summer, drier periods in winter. We then evaluated the relationship between NDVI and arsenic by running a random forest model and found that February was the month with strongest association between arsenic and NDVI. These are preliminary results, and the next step is to include additional variables to build a more robust predictive model.
Trace elements play an important role in the function of our bodies. The understanding of this is still lacking. In this study, we compare published urine metabolomics data for healthy groups with published data for different databases and our data for breast, prostate, and pancreatic cancer. Our goal is to determine whether concentrations of metabolomics in urine samples can be used as a diagnostic tool for cancers such as pancreatic, prostate, and breast, which we find that urine metabolomics can be used as a diagnostic tool for pancreatic, prostate, and breast cancer, as the concentrations in urine pertaining to subjects with these conditions are statistically significantly different to one another, providing a difference to explain a diagnosis. Future work may include collecting data for more metabolomics in urine and from the subjects having other types of cancer, such as lung.
I'd like to invite all of the students in the health segment to now join us on camera for live Q&A. Welcome. So again, to the audience, we're collecting questions in the Q&A box. I've seen one come in that's for Adina. Are there any plans for aiding communities either affected by the arsenic levels or lead levels?
That's a great question. I hope you can hear me. This research is actually through the Strong Heart study, which is a long-term epidemiological study in the Dakotas, Oklahoma, and Arizona. And the research is community-driven, meaning that not only do community members ask the questions that are investigated, but also part of the research is interventions such as water filtration systems, education programs, in order to actually actually impact the communities that are being studied.
Thank you. Another question for Suvik. What would be your strategies for public education, and how could you convey your discoveries to the public?
So right now we're developing some literature based on existing literature that we'll be distributing to our TAP network. And so our TAPs have a pretty strong, I guess, bond with the public. If a community water system exceeds their lead action level, which is 15 parts per billion, then by law, they'll have to reach out to their constituents with materials. So we'll be using information that the EPA provides to create materials and try to reach as many people as possible, especially those in government positions who we work with, usually in cities less than 3,000 people. So we have a pretty big network, and we can reach out to people on water boards and town supervisors and people like that who can then disseminate the information.
Great, thank you. Question for Sonia. Where are the highest lead risks in the US, and how can your map be used in the future? And do you have any recommendations for improving it? So a few questions for you.
Yeah, so this project is actually still in progress, so it hasn't been complete yet. And so we actually don't know at the time where the highest concentration is kind of overall within the entire US, but we do see higher concentrations in general in neighborhoods that are majority Black because of systemic racial inequalities and disparities. And we do see higher concentrations of lead in urban environments simply because urban environments are basically built out of, various synthetic materials, and lead plays a large role in the makeup of urban environments. For the future, I think one of the main challenges is just getting accurate data, because a lot of cities don't release the data or, make it difficult to access. So I think one of the main goals of this map is to make dissemination very easy, so that if you're buying a home or if you're moving into a city, you can be aware of the risks that are posed by the lead in that community.
Great, and then a question for Reese. Can you speak to some of the indicators for predicting food insecurity, and also what were the limitations of your methodology, and how would you improve accuracy in the future?
Yeah, sure. So we used a satellite index called the NDVI, which I believe another intern used, which sort of measures the greenness of an area. And so sort of the backdrop that I mentioned is that actually for just telling from the satellite data what's natural vegetation and what's like farm grown vegetation is very difficult. And so the model has to learn in some way, like what's the average sort of in a region, what's the average amount of natural vegetation versus actually man-made harvested vegetation. And so without a central authority going out to these rural areas in sub-Saharan Africa and reporting on how much of the land is actually being farmed versus how much of the land is just naturally grown, there's no the model finds it very difficult to predict what's the actual food output going to be for those areas. So that's sort of the backdrop, that there needs to be some sort of annual reporting on relative amount of farmed land in these regions.
Okay, great, thank you. Looks like we have had another question come in. So this question is for you, Suvik. Did you find that the rural towns provide spatial data to the public on the location of lead mains and pipes? Because larger cities such as Boston and DC are beginning to release this data to the public.
Yeah, so we were just discussing that. So it's not mandatory to map where lead service lines are located. And actually, it's a kind of a question about privacy matters, and it could impact your real estate value if people know you have a lead service line there. So RCAP has helped, Ohio, for instance, map where lead service lines are located using rudimentary mapping rather than sophisticated GIS programs like that you would find in Denver or Boston. So I personally, think it's a good idea. I don't think, and the law stipulates that you have to have a location identifier for every service line that you find, for every lead service line, or so if you have that, then you can pretty easily map it, I think. And I think that would be, very beneficial to see patterns and see where lead service lines are located.
Great, thank you all. Now we'll move on to the final video segment, which is focused on international development.
My name is Peter Cruz Grace, and I'm a junior studying Earth and Environmental Engineering. This past year, through the Earth Institute support, I was able to work with Professor Yip and his group on a new project focusing on sustainability at the intersection of the desalination and construction industries. My research focused on designing a new integrated system to treat desalination brine and convert it to usable cement for the concrete industry. On one hand, the concrete industry produces nearly 5% of global emissions, and on the other, large volumes of desalination brine are discharged to the oceans every day, damaging the marine environment. However, the high concentrations present in desalination brine offer the ability to transform a waste from desalination into usable replacement for typical cement, thus lowering emissions from the industry. Furthermore, the cementitious materials derived from waste brine act as a carbon sink once used in concrete, allowing for progress towards decarbonization and sustainable development.
Hi everyone, I'm Meredith, a senior in the dual degree program with Barnard and the Jones Theological Seminary. At the Center for Sustainable Development, I provide assistance for many of the office's projects, particularly in research and editing capacities. My position is book research and development intern. In this position, I primarily support research for Professor Sachs's forthcoming book. I don't want to give too much away, but my research has been in a range of topics from the philosophical history of economics to neuroscience to Judeo-Christian theology. I also helped edit the CSD-supported Lancet COVID-19 Commission website, the World Happiness Report, and Professor Sachs's personal website. Finally, I provide support for Professor Sachs's Modern Economics for a Sustainable Planet course at Fordham's Gabelli School of Business. It's been a great experience.
Hi, my name is Jungmook Lim, and I'm a first-year student at SIPA, studying economic and political development. This semester, I had the privilege of being a research assistant for Professors Hoff, Stiglitz, and Demery, and their publication of a new upcoming book that focuses on behavioral economics. Traditional economics has stipulated that everyone acts in a rational way to maximize their own utility. But in reality, things like culture, history, religion can affect that behavior and outcomes in a tremendous way. And this is very important because when you're designing a development policy or intervention, these things must be taken into consideration to not only make sure that these policies have the outcome that they want, but to also make sure that there are no side effects to these policy interventions that have the right intention. The book takes advantage of natural experiments or man-made experiments to show that not everything in development has to rely on RCTs, but can instead rely on historical, natural examples to really see how different stimuli can cause different outcomes in people's behavior. And as a research assistant, I helped them write the appendix that categorized these different papers in a succinct manner to help future researchers take advantage of this pool of data and resources.
Okay, and I will invite Peter, Meredith, and Jungmook to join us for live Q&A now. Welcome. So again, we're taking questions in the Q&A box, and I've got a couple for you. Jungmook, how would you apply a behavioral economics approach to future research?
Right. So I think the research that I did for professors showed us clearly that when you're designing policies to stimulate good behavior for community development or development economics, you have to be always you always have to keep in mind the user or like the person that we're trying to help and their perspective, because a lot of the times I think in economics, we expect everyone to act in a very rational way, act in accordance with like the law of demand and supply. But what the paper shows is that everyone has their own cultural lens through which they look at certain events or certain policies. And I think keeping that in mind is always going to lead to a more effective result than otherwise.
Thank you. Meredith, could you speak a bit to, what was the most important thing that you learned during this internship, and has this experience helped to shape your thinking on future career paths at all?
Yeah, I think I've learned how many interdisciplinary subjects can tie into sustainable development from working at CSD. I've done work in so many different areas that all end up tying back to the same mission. And I think that that is something I want to carry out throughout my future career, in being able to work in a variety of areas, but have a common goal at the end of the day of something that I'm working towards. And I think that the work that CSC does, while it may seem disparate, if there are different policy areas or different groups that CSD is working with, at the end of the day, it's all the same leadership team and strategies that are being employed in all of these different projects. And I admire that from the team a lot and want to continue that in my own work.
That's great. Thank you. And then final question for Peter. What is the commercial viability of this process, and what would be some of the obstacles in scaling your solutions?
That's a great question. So the commercial viability goes a lot into kind of how much a government or the market is willing to price carbon. That traditionally cement is a very carbon intensive process, but this method that we've been working on can substantially reduce the carbon, but it comes at a higher cost in terms of inputting energy, specifically renewable energy. So if there's sufficient support in either cheap electricity from solar or wind or other renewables, or significant subsidies so that the final product can be cost competitive, then it can be commercially viable. But the economics will kind of play out in how much the value of carbon goes in. But the main goal of our project is to make it as cost competitive as possible with current cement without any sort of additional subsidies or investment from outside sources.
Thank you. Well, we're now at 1 o'clock, so I just want to say how impressed I personally was with all of the research and the work that you all have done over the course of the past year. So congratulations. Great to hear about it. To the attendees, in the chat, I posted a link to the Research Showcase website where you can read more about the students and their projects, and the video will also be posted there. So thank you very much for joining us. Happy Friday to everyone. Enjoy the weekend and stay safe.